Hello, this is Professor Torsen. In this video, I'm going to show you how you can use Punnett squares to solve a genetic story problem like shown here. To begin, I'm drawing your attention to this statement here. Cystic fibrosis, abbreviated CF, is an autosomal recessive disorder. This has a lot of information. The word autosomal means that the gene for cystic fibrosis is on a chromosome other than a sex chromosome, so it is not on X or Y. The word recessive also is quite informative because it tells me that an individual must inherit 2 copies of the recessive allele to have cystic fibrosis. When I start any genetic story problem like this, I first like to start by listing the genotypes and the corresponding phenotypes. So I've chosen the letter F to represent the cystic fibrosis alleles. And you can see there are 3 possible genotypes. Capital F, which is our homozygote dominant genotype. Capital F, lowercase f, and that is the heterozygote. And then we have lowercase f, which is the homozygote recessive genotype. So if we list the corresponding phenotypes, because cystic fibrosis is an autosomal recessive disorder, the only genotype that will result in cystic fibrosis is the homozygote recessive genotype. So this will have cystic fibrosis. Neither one of these genotypes, neither the homozygote dominant or the heterozygote genotype, will result in cystic fibrosis. So now that I've got this, I can go back and read through the question and pull out more information. So the first line talks about Mary. Mary has cystic fibrosis and she has a son, Mark, who does not have cystic fibrosis. So Mary has cystic fibrosis, but Mark does not. Well, in terms of their genotypes, if Mary has cystic fibrosis, we know she is homozygote recessive. So I'm going to go ahead and write that next to Mary. Now, Mark does not have cystic fibrosis, which means Mark is either homozygote dominant or heterozygote. We know that he must have at least 1 copy of that healthy dominant allele in order to not have cystic fibrosis. The next line of the story problem talks about Roger. Roger has cystic fibrosis. He has a daughter, Rhonda, who does not have cystic fibrosis. So I'm going to go ahead and write Roger and Rhonda. And Roger has cystic fibrosis, so like Mary, his genotype is homozygote recessive. Rhonda does not have cystic fibrosis, so like Mark, that means she must have at least 1 copy of that dominant allele, but we don't know what that second allele is yet. So there is some information that we don't have. We don't have any information about the other parents, so Mark's father and Rhonda's mother. But we don't need that information. We actually have plenty of information already. So we know that both Mark and Rhonda have 1 dominant allele because they do not have cystic fibrosis. But we know what their second allele is because remember, we inherit our alleles from our parents. So if Mark has a dominant capital F allele, he must have inherited that from his father. How do I know that? Well, because his mom, Mary, is homozygote recessive. she only has the recessive alleles for this cystic fibrosis gene, which means that she can only give a recessive allele to her son Mark. So I'm going to go ahead and fill in Mark's genotype. Now Rhonda is the same thing. We know she does not have cystic fibrosis, so we know that she inherited a dominant allele, and it must have been from her mother because her father, Roger, is homozygote recessive. So Rhonda must also be a heterozygote like Mark. Now that we've pulled all that information, let's go back to the question. Question number 1, what is the probability that Mark and Rhonda are carriers of the cystic fibrosis gene? Well, that is 100%. We know that they are carriers, right? They are both heterozygotes, which means they both carry that recessive allele. Number 2, what is the probability that their children will have cystic fibrosis? Great, now we get to do a Punnett square, my favorite. Okay, so we are looking at Mark and Rhonda. So Mark and Rhonda. And in terms of their genotypes, again, they are both heterozygotes. So I'm going to go ahead and draw my Punnett square. Okay, and I'm going to put the genotype of Mark and of Rhonda like so. Now to fill in this Punnett square, this first quadrant is inheriting a dominant allele and a dominant allele. This quadrant here is going to get a dominant allele and a recessive allele. This quadrant is going to inherit a dominant allele and a recessive allele. And this quadrant is going to inherit 2 recessive alleles. So, if we look at the results of this Punnett square, we can look at the genotypic frequencies or ratios and the phenotypic ratios. So in terms of the genotypes, well, we have 1 homozygote dominant possibility right here. There are 2 possible heterozygote combinations, and there is 1 homozygote recessive. Right, so this is our genotypic result of Mark and Rhonda. But we of course want to know about the phenotypic result because the question asked whether or not they would have children with cystic fibrosis. So in terms of the phenotype, well, I remember from our initial setting up of the question that only the homozygote recessive individual will develop or will have cystic fibrosis. So only this individual here will have cystic fibrosis, 1 out of the 4 possibilities. So the answer for number 2 is that there is a 1 in 4 chance of Mark and Rhonda having a child with cystic fibrosis. Now, if you're more comfortable with percentages, you can think about it in terms of percentages. That's fine. It means the same thing. The answer then would be 25%. The third question asks about the probability that Mark and Rhonda's children will be carriers of the cystic fibrosis gene. So we go back to our Punnett square results, and I'm looking here at the heterozygote. The heterozygotes, remember, are carriers. They carry that recessive allele, but they do not have cystic fibrosis. So 2 of the 4 possible outcomes of Mark and Rhonda are heterozygotes. So 2 out of 4, or if we simplify that fraction, 1 out of 2. Or if you prefer percents, we would say that there is a 50% chance or probability that their children will be carriers of the cystic fibrosis gene. I hope you enjoyed this video. Thanks for watching, and go wash your hands.